3.7 Implicit Differentiation, Part 2. So we're continuing this lesson. Still, your objective is still to differentiate implicitly. Picking up with example 5, we want to find d squared y over dx squared if 2x cubed minus 3y squared equals 8. So we're trying to find the second derivative implicitly. And again, we're doing implicit differentiation because we don't have a y equals. And it's not really easy to get the y equals. You have the square. And so just use implicit differentiation here. So first, if we want to get to the second derivative, we have to find the first derivative. So let's start there. So d dx of the first side equals d dx of the second side. And we're going to differentiate each term in the parentheses. So derivative of 2x cubed is 3x squared. Technically, you could write a dx here since we're differentiating with respect to x, but you know that that just cancels, it goes away. Minus derivative of this is going to be 6y dy dx. So you're treating the y as if it could be something big like a u. Equals the derivative of 8 is a 0. Okay. Oh gosh, why did I write a 3? This should be a 6. So sorry. So that's a 6 because 2 times 3 is 6. Okay. So now I have a 6 on both of those numbers, so I'm going to factor out a 6. So I have 6x squared minus y dy dx. And I can divide both sides by 6, and that really just goes away because 0 times, not times, divided by 6 is still 0. So I have x squared minus y dy dx equals 0. And that's nice because this is just simpler and cleaner now. Okay, and I know I'm trying to get this dy dx by itself, so I'm going to subtract x squared from both sides to cancel. So negative y dy dx equals negative x squared. So to get this by itself, we're going to divide both sides by negative y. And we end up with dy dx equals x squared over y. And this is just because your negatives canceled. Okay, so this is our first derivative so long as y is not equal to 0. But we don't want the first derivative, we want the second derivative. So d squared y for dx squared equals d dx of x squared over y. Okay, so now we have some division. What do you use when you have division? You use the quotient rule. So you know that that would be, write this in different color here, low d high minus high d low over low squared. So low d high minus high d low over low squared. But in this case, low is y and high is x. Okay. So this is equal to then y times derivative of the top is going to be 2x minus x squared, derivative of y, dy dx, over y squared. Okay, so let's put this in a little bit more conventional writing. Y times 2 times x is 2xy minus x squared dy dx over y squared. And the part that's bothering me a little bit right now is this dy dx. I want to get rid of that. I'm going to substitute with this. I already know dy dx is x squared over y. So instead of writing dy dx, I'm going to put in x squared over y. Okay. So I have then 2xy minus x squared times x squared over y all over y. And I can simplify this. This is x squared over 1. So I have 2xy, and I'm going to break up my fraction here. So over y minus x squared times x squared is x to the 4th over 1 times y is y. This is divided by y over 1, which remember is the same thing as times 1 over y. So we have 2xy over y minus x to the 4th. Oh gosh, that was a y squared. Let me change those to squares. So x to the 4th over y cubed, because 2 plus 1, we get a cubed. Okay. And the last thing to go, over here I see I have a y and a y, so those are going to cancel. So I have 2x over y minus x to the 4th over y cubed. My restriction is as long as y does not equal to 0. So this is y double prime, my second derivative. Okay. The power rule for rational powers of x. This again should look familiar. So if n is any rational number, then ddx of x to the n equals n times x to the n minus 1. If n is less than 1, then the derivative does not exist at x equals 0. So that's only when x is not x, n is less than 1. Example 6, 3 parts here. So we're trying to find 3 different derivatives. Let's just start with part A. Okay. So I know that ddx of square root of x is the same thing as ddx of x to the 1/2, because I can rewrite that square root as x to the 1/2. And when I'm taking the derivative, I'm going to take that 1/2 and push it into the front. So 1/2 x, and I subtract 1 from this. So 1/2 minus 1 is the same as 1/2 minus 2/2, which is negative 1/2. So I have x to the negative 1/2. And now I'm going to rewrite this so I don't have the negative exponent. So really on top right now I have 1 times x to the negative 1/2 over 2. But I know that when I have a negative exponent, I can drop it down to the denominator. So I have 1 over 2x to the 1/2. And again, x to the 1/2 is the same as square root. So I'm going to say 1 over 2 square root x. And this is my answer. Okay? So, yes. And please keep in mind here that this is not defined when x is 0. So x can't be 0 for here, even though x could be 0 here. Part B. Yeah, let's move C out of the way first. Okay. Part B. Doing this one in green. So, same idea as before. We're going to take this exponent and make it a coefficient. So 2/3 x, and 2/3 minus 1, which is 3/3, is negative 1/3. So x to the negative 1/3. If we were to rewrite this, we're going to have 2 over 3 x to the 1/3, because the negative exponent pushed us into the denominator. And you could leave it like this. You could also, if you desired, write that as the cube root of x. So 2/3, or 2 over 3 cube root x. So either one of these would work. And part C. I believe this is our last problem. Yes, it is. Last problem of the section. Let's push through it. Part C. Okay. So we have d dx of cosine x to the negative 1/5. Going to drop down that negative 1/5. Write what I still have left. Raise it to, well, what's negative 1/5 minus 5/5? It's negative 6/5. Okay, but we have an inside function, which means that we're going to apply the chain rule. So times d dx of cosine x. So this is negative 1/5 cosine x to the negative 6/5 times the derivative of cosine x is negative sine x. Okay, so now I have a negative and a negative here and here. So those cancel out. They both become positive. And I'm left with 1/5 sine x cosine x to the negative 6/5. If you want to rewrite this like this, so that cosine has a positive exponent, that's fine. Do your thing. I'm just going to leave it like this. Okay, so that is it for 3.7. Don't worry, there's still more chapter 3 to come.